Okay, here's question 2 from 2016. This looks like a particle motion problem, okay? We have v of t, velocity. They tell you an initial point. Here we go. Is the particle speeding up or slowing down? So remember, if you want to know whether the speed is increasing or decreasing, you have to check for two things. You have to check for velocity at that moment, and you have to check for acceleration at that moment. Okay? Acceleration is really just the derivative of velocity. So plug that into your calculator. Feel free to text me if you actually don't know how to do it on your calculator, but I'm going to move ahead. V of 4, the velocity at time 4 came out positive. The derivative of velocity, which is acceleration, okay, came out negative. So what does it mean? There you go. The particle is slowing down since V and A have different signs. Now, if they both share the same signs, the speed will always be increasing or going up. Okay? So even if it's positive, positive, or negative, negative, the speed will increase. Okay? But if the signs are different, you know the speed will always decrease. All right? Here's part B. So from 0 to 3, find where the particle changes directions, okay? The particle will change directions at a critical number. A critical number is where the derivative is 0. The derivative, in this case, is v of t, which is what they give you. Okay, so what you do is you're going to graph your y1 here, okay? You're going to graph this here, and you're going to find out where the particle cuts through the x-axis from 0 to 3. So you can actually minimize your window, limit your x-min to 0 and your x-max to 3, and then calculate your 0. Second, trace 2, and then you pick some safe left and right bounds. You should get t equals 2.707. Okay? So it does say justify your answer, so we know it's 2.707 since the particle changes directions. Actually, no, I should put it here. Since v of t changes from positive to negative. Okay? Now, really, you don't need positive to negative because a change in direction, it doesn't matter what you start with, really. So I would just say v of t changes directions at t equals 2.707. All right? Here's part C. Find the position at t equals 0. Okay, position. How do you go back to position? This is going to involve integration. Okay? So we have to integrate v of t to go back to position. All right? So again, we want to know the time at 0. Okay? So here's what you do. We want to know our time at 0, but we have to consider a starting point, okay, an initial condition. So here they tell us that the particle is at 2 at t equals 4. So I'm going to put 4 here. Actually, I'll use a different color. But you guys have to consider where you were at 4. Okay? So at t equals 4, you were at 2. Okay, this is just one way. I'll show you the other way, and I'll let you decide which one's easier to understand. Now here, this looks a little bit weird because the bounds are mixed up. So this is the same thing as 2 minus the integral from 0 to 4. The other approach is this, okay? If you want to know t equals 0, okay, notice how the time that they gave you is after the time that you want. So you're actually going backwards here. If you want to know your position at 0, you have to accumulate from 0 to 4. But you have to consider what you end with now. Okay, what you ended with was 2. But if you're going backwards, if you're walking back to 0, you have to go minus. Okay? Personally, I think My initial explanation was a lot easier to understand, but I'll leave that up to you guys. Okay? Here's the last one, part D. Find the total distance the particle travels from t equals 0 to t equals 3. Okay, total distance. Okay, there's two different parts, total distance and displacement. Try to remember what the difference is between the two, okay? Total distance is really the integral of not just v of t, because that's displacement, but it's actually the integral of the absolute value of v of t from 0 to 3. This is a quick plug and chug problem. You would go to math 9 to get your integral, and to get your absolute value, you would go to math, right arrow, and then it should be the first one that says ABS, and then you type in alpha trace y1 from 0 to 3, dx on your calculator. That's a quick plug and chug there. Okay? If they were asking for displacement, you wouldn't need the absolute value bars. Okay?